so this is day 3. We're going to continue with our surface area. And today we're learning about pyramids, cones, spheres, and hemispheres. So for a pyramid, this is a 3-dimensional solid with one base. The base can be any shape, and it comes to a point. So we don't have 2 bases, just one. All right, so the surface area for the pyramid, we're going to find the surface area for each face. So the base area, whatever that base is, if it's a rectangle, length times width, or base times height. For the triangles all the way around, we use the formula 1/2 base times height. However, the height is represented actually on the side here with the letter L, and that is considered the slant height of the triangle. For a cone, we have slant height again. It would be on the side here. I use a cursive L so it doesn't just look like a 1, but you can write any L you want. Okay, so for the surface area for the cone, the pi r squared, that's representing the base of the circle. So if I write base here, plus pi rl, so pi times r, which is radius still, times L, the slant height, that's representing all the way around the cone. So around cone. A sphere is like it's a 3-dimensional solid where each point is equidistant from the center. So if you think of any ball, it's a sphere, 3-dimensional circle shape. That's represented by the equation 4 pi r squared, where r is still your radius. A hemisphere is a half of a sphere. Well, what's the equation for that? So let's think about it. Why is it 3 pi r squared instead of a half of this would be 4 divided by 2? So half of this would be 2 pi r squared. So why isn't this 2 pi r squared? Well, we have the half of the sphere, and then we have to add the surface area of this circle on the top. So really it's 2 pi r squared plus the circle on the top area, 1 pi r squared, which does become 3 pi r squared. So it's good to understand why it's 3 pi r squared. All right, let's begin our examples. It says classify the following shapes as either cone, pyramid, including the base shape, or sphere. Then find the surface area. So this shape is a pyramid. Now what is the bottom? A rectangle. So it's a rectangular pyramid. Okay. So to find our surface area, we're going to find the area of each of the faces, add them together. So first, our rectangular bottom. That's a 9 by 4, so I'll just do 9 times 4, 36. Then our sides. So this triangular side on the right is the same triangle as this one over here on the left. So what I'm going to do is whenever I do my triangle, I might write what the base is. Okay, the base of that triangle is 4. And there's going to be 2 of these, so it's 1/2 base 4 times L slant height, which is 8.3. And there's 2 of those, so times 2 at the end. Plug that into your calculator, you should get 32.2. Now for the large triangle, the one that's facing us here, this face, there's one on the back side as well. So that triangle's base is 9. So that's 1/2. Base is 9. Slant height is 7.3. And there's 2 of those. So I should get 65.7. Surface area is me taking all of these faces, adding them together, and you should get 134.9 kilometers squared. right. Number 2. We have a cone here, so we need to do the base circle plus a round. The base circle is pi r squared plus a round pi r L. So it's kind of like, circumference is 2 pi r, but slightly different. So plugging in what we know. Radius is 9, so pi 9 squared plus pi times 9 times slant height, 20.1. We'll leave it in terms of pi until we get it all simplified. So 81 pi plus 9 times 20.1 is 180.9 pi. Adding those together, 261.9 pi. Plug in 261.9 times pi into your calculator, 822.8 feet squared. Number 3 is a sphere. So our formula is 4 pi r squared. This 16 is representing your diameter. So a radius from here to here would be 8. So 4 pi 8 squared. Plug that into your calculator. You should get 804.2 centimeters squared. Sphere, 804.2 centimeters squared. Number 4. Okay, we have another cone. At this point, pause it and try this one on your own. So here our radius is 5. So we're going to go do the base plus a round. The base is pi r squared, so pi 5 squared plus a round pi radius times slant height. So 25 pi plus 56 pi, that's 81 pi. 81 times pi in your calculator ends up being 254.5, and it's yards squared. This next one is a half of a sphere, so we call this a hemisphere. So the equation for that is 3 pi r squared. So your r is 5, so 3 pi 5 squared. Plug that into your calculator. 3 times pi times 5 squared. It's 235.6 kilometers squared. The last one. This is a pyramid, and we name it by its base. So its base has 6 sides. So it's a hexagon, or hexagonal pyramid. Pyramid because it comes to a point. Okay, so this base here, the formula for this regular polygon is 1/2 times apothem times perimeter. So 1/2 times the apothem, which is 5.2, times the perimeter. So each of these sides is 6. So 6 times 6 sides. Plus the triangles, there's 6 of those. So the triangles are 1/2 base, which is 6, slant height, which I'm giving you here, 13.1, and there are 6 of those, so times 6 at the end. We're just simplifying in our calculator here. So for the bottom, the base, I got 93.6 plus. For all of those triangles, each triangle face, then times 6, 235.8. All of the faces added together, so surface area now, 329.4 kilometers squared. Number 7, find the surface area of each composite solid. So what do we have here? We have a cone on top of a hemisphere. What don't we need? We don't need the base of the cone or the top of the hemisphere. So let's start top down, around the cone. That's pi RL. So pi is, we'll say pi, R, the diameter's 8, so the radius is 4. L is slant height, so this comes out to 48 pi. Now for the hemisphere here, it's actually the hemisphere without the top. So instead of 3 pi r, I can make it 2 pi r squared. So 2 times pi times 4 squared. 16 times 2 is 32 pi. Surface area is me adding those two things together. So 48 pi plus 32 pi equals 80 pi. Type that into your calculator. 80 times pi. 251.3 inches squared. Number 8, what do we have here? We have 2 cones sandwiched in with a cylinder. So the cones, we don't need the circle bases as well as the cylinder. So let's look, are the cones the same size? They should have the same radius because they're fitting on the cylinder correctly. Now this cone has a slant height of 3 and this one's 4, so this side's slightly longer. So I can't just do one cone and times it by 2. So let's do, I'll call this cone number 1, and this is cone number 2. So cone 1, it's pi RL, just around the cone. So pi, radius is 2, L is 3. So this comes to 6 pi. Cone 2 now, pi times 2 times slant height of 4 this time, 8 pi. Now for the cylinder. So this is throwback to last class, around the cylinder. So think about it. Around the cylinder ends up being a rectangle. We have height here, but around the bottom is around the circle. So instead of base times height, the base is the circumference, 2 pi r. So we have 2 pi, radius is 2, times the height, the distance between the circle bases, is 3. So this should be 12 pi. So the surface area is me adding all 3 of these up. So 26 pi. Plug that into your calculator. 26 times pi should be 81.7 meters squared. I have one thing I want to touch on in your homework. Questions like number 8.
Just a quick bus announcement, more of a
Give
bus
us 1
update.
second.
Bus 88 will actually be back in our lineup today. So bus 88 is here today at NGC. Thank you.
All right. So in order to find the area of this triangle, I need the slant height. Right now I have the actual height of the entire pyramid. So in order to find the area of like just one of these side triangles, I have base, I need slant height right there. Okay, well, how do I do that? Inside this triangle, or inside the pyramid, I can cut out this slice of this triangle. Given this height of 20, the base here is a square, so that means this is 15. I could find the slant height using Pythagorean theorem. So it'd be This L is across my right angle, so that is going to be the hypotenuse. So 20 squared plus 15 squared equals L squared. So 20 squared plus 15 squared, I think is 625. Yeah. 625 equals L squared, so L is 25. So now you should be able to say, all right, if L is 25, then for my triangles, it's 1/2, base is 30, slant height is 25, and how many triangles are there? There's 4. Then for my square bottom, it's 30 by 30, so 30 times 30. If we get there, add them together, surface area would be adding those two together. You do have to do something similar for 10, and let's assume this is a square for 10. All right.